Okay, and so without further ado, let me just start by introducing to you what is industrial and systems engineering. So the the one difficulty that people have is so a lot of people they know what is mechanical engineering, they know what is civil engineering, because you can see bridges, you can see buildings, you can see structures. So people can appreciate what is civil engineering. So, but what is industrial and systems engineering over there? So the difficulty stems from the fact that systems is something abstract. It's not something concrete that you see over there. But very loosely speaking, a system essentially it's a set of things that are working together or interacting with each other. So if you're to think about it, a manufacturing facility, that is a system. That is where you have manpower, you have workers, you have machines, and essentially you have raw materials. And they come together to to convert the raw materials into finished products over there. At the same time, supply chain is going to be a system. You have all your inventory, your goods, and you have your transport vehicles, and essentially you have your delivery points over there. So you need to pick up the items from one point, use the transportation vehicles to deliver them to your end goal over there. That is another system. If you think about the banks, that is also going to be a system as well. You have your counter staff, you have customers going in requiring services, and once the service is done, then the customer would essentially leave the bank over there. So that once again is going to be a system. So essentially a system is a very broad concept, and that is what ISE is about as well. That essentially we're going to be interested in solving problems and improving systems. And this is going to apply across a broad range of industries, simply because these are the tools and techniques that we use will apply to systems, which, as I mentioned, is going to apply to a wide range of different areas. And so the best way to probably understand what is industrial and systems engineering is to think about the tools that we have. And so here I've highlighted four to help with my explanation today. And so there's going to be data analytics over here, where essentially for us to improve the system, we need to understand the system. And so that's where data analytics comes in. By making use of the data, we will then go about to understand the system before we think about improving it. The second tool that we have is going to be simulation. So sometimes you are going to be dealing with problems where you don't have data or you don't have the right type of data over there. Okay, and so under those situations, another potential approach that we can do is that we can build a simulation of our system, and from there to better understand the problem that we're going to be tackling. Or another advantage of simulation over here is the ability to do what-if analysis. So once I have a digital twin of, let's say, my real-world process, then I will be able to analyze that, oh, if I was to add in one more manpower, how much is it going to reduce my waiting time and so on. So sometimes this is going to be difficult with just data analytics alone, because sometimes you go to a company, the company says that, oh, okay, I've only hired 10 people. So I don't have the data for what happens if I hire 11 people, or what happens if I've hired 12 people. Of course, we can do predictions, but that is where there's going to be a certain amount of uncertainty over there. So that simulation is going to be a second tool that we use very often. The third tool that we use is going to be optimization over there. Sometimes there are going to be too many possible solutions, and we don't want to explore all of those solutions. And so what optimization does is that it allows us to very efficiently look for the best solution. And at the end of the day, what we're going to be interested in is going to be decision making over there. And so we're going to have various decision making skills, for example, the cost benefit analysis and also sensitivity analysis and so on. And so collectively, these tools that we have are going to help us to basically analyze the problem and then solve the problem and also improve systems. And these tools, they are going to be well grounded in mathematics and also computer science. And so that's why for our undergrad students, we train them in linear algebra, we train them in calculus, statistics, probability, and also programming. Okay, so these tools are, it's not it's not a tool that you can just pick somebody off the street and then we can do it. Or it's not like sort of like I can just give you a 1 hour tutorial and then you can build a simulation or you can do data analytics or optimization over there. Okay, so it has to be grounded in terms of the mathematical fundamentals. And then from there, you know how to efficiently apply these tools. So if you think about it, the typical approach that we do is going to be, we go in, we analyze the problem, and then we look for innovative solutions. And then after that, we want to optimize to figure out the best of the solutions over there, leading to final decisions that we are able to recommend to management. So that in a nutshell, it's kind of what industrial and systems engineering is all about. And so what I want to do next is let me just share with you some of the projects that our students have done. And that will give you a better glimpse as to the type of problems that our students solve, and also how our students actually make use of these tools that we equip them with to go about to solve the problems that they have. And also importantly, why is it that they are able to help influence the decisions of management? So the first one is essentially the project that our students have did with Shopee. And this is what we refer to as the systems design project. And so for all our undergraduates, they have to enroll in this nine-month long project. So it's across 2 semesters where they will be attached to one company. And so they are going to act as consultants for this company. So they will go in, they will hear from the company what is the issue that the company has, and then they will go about to analyze the problem, innovate, optimize, and then come up with good decisions for them. So this was a group that worked with Shopee. And so the problem given to them was that they have a lot of aging stocks in their warehouse. So companies do not like to have the stocks to stay too long in the warehouse, because all this inventory is going to take up space, is going to take up cash over there. Okay, and so companies like these inventories to keep moving. They don't want it to stay in the warehouse for too long. And so that's going to be a problem. If you are familiar with the concept of opportunity cost, you will then appreciate why companies do not want to hold on to stocks for too long. Okay, if you don't worry. You join us in your second semester. When you take one of our modules, you will learn more about opportunity cost over there. Okay, but if not, just take my word for it. Companies like their inventory to keep moving. And so what the team went in was, they analyzed the problem, and then essentially they came up with 2 resolutions for them. The first one over here is in terms of their demand forecasting. So they went and looked at how Shopee did their forecasting, their current approach, and basically they came up with their own way of performing the demand forecasting. And so across some of the categories, they were able to help reduce the prediction errors by up to 70%. Across some of the other categories, the improvement was about 30% and so on. Okay, but this is one thing that I think it's very valuable of our ISE students, which is that when we make improvements, we quantify things so that people will then be able to know how much value we are bringing to them over there. Okay, and so basically what the group did was they went in, they realized that one part of the problem was in terms of the demand forecasting. And this was one area where they can improve. And so once they have improved the demand forecasting, but this is still not the decision, right? Basically, we're just predicting what is the demand going to be. So later on, you need to make the decision in terms of if I was to overorder, what would be the issue? If I was to underorder, what would be the consequence? And I kind of need to reach the right balance between them. And so then the group went on to do an integrated approach in terms of helping Shopee to manage their inventory over there. And so they demonstrate using by doing back testing over there to say that if they make use of this integrated approach, then they would be able to reduce the amount of aging inventory in the warehouse by half, from 20% to 11% over there. Okay, and so this is basically just a quick illustration about how our students make use of data analytics to analyze the problem and also to come up with prediction models. This would come in the realm of machine learning and essentially translating that into decisions for the stakeholders. And more importantly, the key thing over here is that you need to have very quantifiable performance measures over here. Okay, so that straight away when a company see this, they will know that, oh, okay, yeah, you have brought this amount of value to me. So next, let me just go on to another example. So this is a second example that we did with Infineon. So if you're not familiar with Infineon, it's a semicon manufacturing company over there. So they produce a lot of these semiconductor products. And so this is going to be in a manufacturing setting over there. And so one problem that they have over here is, so a lot of things are automated. So let me just bring this up over there. So a manufacturing floor is going to be big. Okay, and what happens is that there are going to be workers who are doing jobs over there. They are testing to see whether if this job is operating well or not. And what happens over here is that once they are done with the job, they need to call for the next job to come in. And the delivery of the jobs are actually done by these automated guided vehicles. And these automated guided vehicles, essentially what happens is that once a job is called, there'll be a centralized system that will pull the job. The automated vehicle goes over, pick up the job, and then bring it to that workstation over there. And so the problem that was tasked to this group was essentially what is going to be a good dispatch route. So if we wait until I finish this job and then I call for the next job, this machine is going to be idling very long, especially when I call for the job and all the AGVs are busy at that point in time. And so what the group did was essentially they built a simulation over here. And before they can build the simulation, they need to gather some data. So they gather the data, they built the simulation. And then what they did was essentially they were then able to test the different type of dispatch rules over there. So should I dispatch it 30 minutes beforehand, 25 minutes beforehand, 35 minutes beforehand, and so on. And so what we need to do then is we need to talk to management. We need to understand from management what is going to be of interest to them. So they're going to be interested in the machine idle time. They're also going to be concerned about the lots are arriving too early because it brings along with it its own set of complications over there. And so you're going to realize that there is no free lunch. If we call too early, then basically the lots are going to arrive too early. But if you call too late, then your machines are going to idle too long over there. So, but with the simulation, what the group is able to do is that they're able to test out different dispatch rules, and then they can see the impact on the different KPIs. And then from there, they can highlight that 30 minutes is going to be the most ideal trade-off for this particular problem that they have. And so this is one example where essentially the students make use of simulation. And by making use of the simulation, we can do these types of what-if analysis, resulting in recommendations that we can make for the management over there. Okay, and so once again, over here, straight away, you can see the value that our students can bring, right? Because you can see under the old approach, how much time the machines are idling over there. And then now based on the new dispatch approach, how much we have reduced the machine idle time. And straight away, the management can do some easy back of the envelope calculation, right? How much it costs me to purchase this equipment and run this equipment each year. And now if you are able to reduce the idle time by 10%, then basically that is the amount of cost savings that you have arrived from. Okay, so once again, this is how we are able to demonstrate the value to our potential clients or employers over there. The third example that I want to talk about is going to be optimization. So I've already talked about data analytics. I've talked about simulation. So the last example I want to share with you is to highlight about the problem of how optimization can be used to tackle some problems. So this was actually done with the Singapore Police Force. The problem on hand is when they have a major event. Think about the National Day Parade. Think about the Chingay. The police would actually need to be on standby to react to any type of situations that may occur. And so the problem task to them was essentially, where should the police be deploying their officers and their logistics? And we refer to that as essentially a forward base over there. So the police is asking us, how many forward bases do we need to have? And how many officers and how many inventory do we need to put at each of these forward bases? So we got from them. So obviously this is not the actual one. So but we got from them essentially the critical points that need to be covered. And then in the event something happens. So for example, this is a critical point. If something happens over here, if we have a forward base at location 1 over there, then this group of people will be able to react to that situation over there. Assuming that we have the right amount of manpower, we have the right equipment. If we don't have the right equipment, then we need to get people from location 2 over there. Okay, and so what happens over there is that if we didn't have the right inventory at location 1, we need to pull items from location 2 then the response time is then going to be increased over there. So the problem we have on hand is how many of these forward bases we need and how many manpower and inventory to put at each of these bases. And the objective given to us was we want to reduce the response time that is required to react to those situations. The decision variables I've already highlighted. So where do we want to build all those? So as you can see, then there are going to be an infinite number of possible places that you can put, right? And at the same time, there's going to be a infinite number of potential forward bases. You can put 1, you can put 2, you can put 3, and so on. Okay, and so this is why this is going to be an optimization problem. You don't want to analyze all possible solutions. There are too many to analyze them. And so what we want to do is that we want to actually have a very efficient way of addressing this problem. So linear programming was actually used to tackle this problem. So the gist of the matter is we have a problem at hand. We use mathematics to model this problem. And once you model this problem using mathematical equations, you can then make use of the mathematical properties to efficiently look for the best solution that you have on hand. Okay, and so that's what the students did. And besides that, obviously, most of the people at the Singapore Police Force, they are not trained in linear programming, right? So what our students did was they made use of Microsoft Excel to implement the optimization tool. And so the police were able to put in their own information and come up with the forward plan over there. And like I mentioned just now, the problem that they gave us was not going to be the actual layout. So this was basically just a pseudo problem that they gave us. Okay, but we gave them a decision tool that then they can go in and use their own real data to figure out what is going to be the best plan over there. And they like it because they, you know, if you they don't know how to do optimization, and then they don't have a lot of people who know how to do Python as well, right? So they want you to give them some Python code. They want you to just give them something that straight away they can just go ahead and use it. So everybody inside there, they knows how to make use of Excel, and so and they can just go ahead and change the numbers, and they can see the impact of it. So that's why in our first year course also, we actually train our students to learn how to make use of Excel to build these types of decision tools. So very quickly, so this is an example of an optimization problem and how it can be used to recommend decisions to our stakeholders. So with that, I hope I have demonstrated to you how our students actually can bring values to companies. So in Shopee, basically by reducing the amount of aging inventory, very quickly you can calculate how much inventory costs we are reducing for the company. In the Infineon example, we reduce the machine idle time. So based on how much your machines are costing you, straight away we can figure out how much equipment costs we're reducing for you. For our Singapore Police Force problem over there, essentially we can say under the old plan, how many forward bases do we need? How much manpower do we need? Under the new plan, how many forward bases do we need? And so the manpower savings is going to be easy to calculate over there. And so because of this, our graduates actually do very well in terms of the employment. So these are the employment statistics of our graduates. So this is the graduate employment survey that's done by MOE every year. So you can easily just get this information off the MOE website. So our graduates do well both in terms of the employment rate and also in terms of the salary that they receive over there. But what I want to highlight over here is that you realize that there's going to be a whole host of information over there, right? And that's going to be very difficult to process. Okay, and so this is what we refer to as information overload. And over here, these are essentially just only for engineering. And so there are going to be a lot of other degrees as well. So how do we go about to process this information? An easy way over here is to basically just plot it as a scatter plot. So on my x-axis over here, you see this is going to be the full-time employment. And on my y-axis over here, this is going to be the median salary. And so ideally, you want to be at the top right corner over here. Okay, ideally, you want to be in a program where we have full-time employment, where you have high employment and also high salaries over there. And so from here, you can see that industrial systems engineering is going to do pretty well, both in terms of the full-time employment and also in terms of the median salary. So recall just now, I gave you a whole host of numbers, right? But once you see so many numbers, it's very hard to make sense of it. But once you are able to represent the information in a way that is going to be relevant to the decision that you're making, then straight away people will be able to make use of that information to arrive at the decision. So this is going to be the one last example I give to you in terms of how we can make use of data analytics to analyze the problem, resulting in terms of a decision over there. Okay, and so we do have a write-up on this. So, and it's not just this year. Year after year, our graduates actually do well. And in fact, even last year, due to the COVID-19, many degrees were actually impacted, but our students were very resilient in terms of their employment. I'll talk a bit more about that later. But here I have we have this article over there, and in fact, Chris is one of our students who fourth year student, but he has already secured employment even before his final semester. So he has gratefully shared with us some of his thoughts on it as well. So the article is on this link over here that I share with everybody. So during your own free time, you can just go about and take a look at it. Okay, but let me just move on next. So in a nutshell, hopefully I've shared with you that our graduates have a useful set of analytical computing managerial skills that can be applied across multiple industries. So on our website over there, we actually have a listing of the LinkedIn profiles of our alumni. So you can just go ahead over there and see what are the industries that our alumni actually are currently working in. So let me just share the link with you as well over here. And so you'll see that they are going to spread out in business, finance, digital technology, government, services, manufacturing, supply chain, and logistics over there. Okay, so a few key points to note over here. The fact that our graduates have a useful set of skills means that they are able to seek out the best paying jobs over there. And I hope you can see why that's not difficult. Because after the systems design project, we can say that, I'm able to help Shopee reduce their aging inventory by 20%. So straight away, the company that you propose to join, they can see the potential value that you can bring to them. If I bring in this person, if this person can reduce my machine idle time by 10%, how much cost savings is that already? So very often, our graduates already, they are worth their weight in gold. They go into the company, they save more for the company than what the company is paying them already. And it's not just the point that the skills are useful. The other thing to take note of over here is that it's going to be applicable across multiple industry, which is why our graduates are spread across different industries over here. The second advantage over here is that you are going to be resilient. You are protected against industry-specific type of shocks or trends over there. So as I mentioned, if you were to look at last year's GES numbers, our graduates were still finding employment. Okay, and so we were not as negatively impacted by the COVID-19 as some other degree programs over there. So I think that this is something that is also worthwhile to note. But the third point, which I think is the most important, which I think it's not highlighted enough, is that because of this flexibility, you are able to find employment in the industry of your interest. So if there's anything that you take away from today's sharing, I hope this is what you get, which is that at the end of the day, I think you should find employment in an industry that you are interested in. So I mean, don't be too caught up. Don't sort of like straight away say that, oh, I only like to go into this industry. You need to be open over there, but you need to be honest to yourself as well. Okay, you don't want to dread going to work every day. So at the end of the day, you're only able to perform well if you are in a job that you like. You are in the industry that you like over there. Okay, and so I think that this is underemphasized, but we train our students with a useful set of skills that can be applied across multiple industries. And this gives our students the flexibility in terms of finding where they like to go into over there. Okay, and I think that this is going to be very, very valuable. It is only when you like your job that you're interested, that you can excel in the job that you are doing. So very quickly, let me just give an example over there. So recall our Infineon example. So one of the team members for that group was Henry. So this was actually with a manufacturing plant for this project. But subsequently, Henry, he went on to join a tech startup over there. So his interest was in terms of startups and also the digital technology. And so Henry went on to join a tech startup. And he can, because he has these relevant skills over there. And in fact, for Chris, later on, perhaps he might share. I mean, his SDP was also in one area, but then later on, he will be going to work in the finance industry as well. Okay, and so that's a flexibility that our students have. But I think that it is important that you need to have options. We live in a world that is always changing, and you are in the process of discovering what you actually like. And I think this is a valuable attribute that our degree program actually offers to our students. So I hope I've convinced you why industrial systems engineering is great. The last thing that I want to talk about is why our department, why NUS over here. So I'm going to tell you that we've been training engineers since 1969. So we've been around for a very long time. And what it means is that we have extensive industrial connections and collaborations with universities overseas. And in fact, with top universities overseas over there. And the NUS brand name, the ISE department brand name is going to be important, because if you think about your education at the university, so besides the curriculum, the skills that you learn, there are two other things you want to think about: the industrial experience that you're going to gain, and also the study abroad opportunities, which I think these days everybody is looking forward to, right? So we're glad that the COVID situation seems to be, I hope I can use the word abiding, and then that we can start to have more of these study abroad options over there. But from these two dimensions, let's just take a look at it. So because of our connections with partner universities overseas, we are able to have summer and winter programs for our students. And at the same time, we're going to be able to give our students a lot more choices in terms of the student exchange program. And let me just give you one example. So in the US, Georgia Tech is actually the top industrial and systems engineering department over there. And so we have a summer program with Georgia Tech every year. And because of our summer program with Georgia Tech, we actually, we do have additional student exchange places to their university over there. And so our students are able to, a lot more of our students are able to experience study abroad at Georgia Tech because of this collaboration that we have with them. And at the same time, the Georgia Tech students have the opportunity to come to NUS to experience our education system as well. In terms of the industrial experience, this is where I've mentioned about the systems design project, because we have worked with a lot of companies, and we have done a good job with these companies, and so we continue to receive good projects from them. And I hope you can see that these projects are going to be very important to help build up your CV, to build up your resume, which is essentially going to be very helpful when you start to apply for your job. Not just the systems design project, for the internships as well. So because of the NUS brand name, we have a lot more connections with these industry partners. But of course, these days, we don't encourage you to just rely on the university for internships. I think companies also like students to be proactive in terms of getting those internships as well. Okay, finally, we have the NUS Overseas College over there, which is where you will be joining a tech startup, and you also be taking classes overseas as well. So it's going to be an intersection of that. But I hope you can see from here that the brand name does matter. Okay, I think that it has taken us a lot of time, a lot of effort to build up these connections, but the fruits are paying off. And we are very, very happy that these are the benefits that we can bring to our students. So I think that is probably all that I have to share. So just a few pieces of information over here. So I hope I've gotten you interested in about what is industrial and systems engineering. To find out more, you can visit our website over here. We have an eOpenHouse website where we've put up the relevant information that may be of interest to you. Okay, and so let me just go ahead and share this link with you as well. So do check it out on your own free time to to find out more about what is industrial and systems engineering. And at the same time, we have a series of events lined up. Let me just share that link with you as well. And so over here today, 27 February, this is our eOpenHouse. And this Sunday, which is today, right? Our eOpenHouse. And then next Saturday, what we're going to have is that we're going to have a physical open house. And ISE, we're going to be in Gallery 5 over here. The registration, I'm told, has already been open, and in fact, I think the places are being snapped up. So unfortunately, because of our safety distance measures over there, there's a limit of the number of people that we allow to each of the sessions. So do go ahead. If you're interested, do go ahead and sign up for one of these sessions. Our professors, our students will be there to interact with you. So if you want to have some interaction with our staff, with our professors or students face to face, this will be the opportunity. And then the following Saturday, which is 12th of March over there, we're going to have a ISE dialogue session. This is where we will get our head of department, Professor Ng, and we get our deputy head of undergraduate, Professor Chu. So if you're interested to find out more about our undergraduate curriculum, do join us for this session. Professor Chu will give a more in-depth elaboration about that. So today, basically, I'm just giving a broad overview. And this will be a good chance for you to interact with our head of department and also our deputy head of the undergraduate program. So this one, there's no limit. It's going to be an online Zoom session. So just go ahead and sign up for it, and we will send you the Zoom invite over there.